Hello, in this video we're going to be talking about phase and vertical shifts, and we'll still be doing amplitude and period, but the focus will be on phase and vertical shifts. Starting with phase shifts. Phase shifts are a value that are being added or subtracted on the inside of our sine or cosine function. Now note that we have to make sure that this b is factored out. If it is not factored out, we do need to factor that thing out. It is a little backwards and weird. So if we see addition, you would think, go to the right. No, no, no. It goes to the left. And if you see subtraction, it's on the inside. So it's all backwards and weird. So if you see that subtraction, you need to move to the right. So, fun fact, I was just talking about how it's all backwards and weird, but I actually just did this whole problem and then discovered I did it wrong. This one has a phase shift of pi, and we want to move it pi to the right or to the left. Well, it's going to the left. It's all backwards and weird. You'd think plus would be to the right, but it actually goes to the left. I actually did the whole problem wrong, and so now this is take two of the same problem. Our period is going to be taken from our b value, which is 1. So our period is going to be 2 pi over whatever our b value is, which in this case is 1. So that's 2 pi. So it's going to be have a normal period, and our amplitude is 1. Again, that is how far up and down we need to go. So I'm going to go WRMP, and I'm going to go WRMP, and I'm going to leave it a little bit more space to the left, or the left, because I'm going to need to go to the left in just a bit. So make tick marks as usual. 1, 2, 3, 4 tick marks, and we write our period, which is 2 pi, and our halfway point, which is pi. Now we want to move pi to the left. So I'm ahead of myself. I want to get my amplitude. I'm just so excited for that phase shift. So we're going to go 1 to -1. Okay, now, normally I would be starting right here, but I need to move pi to the left. So if I look right here, I've got 2 tick marks, and those are representing pi. So if I make 2 tick marks in the opposite direction, that'll move me pi to the left. Great. But where is this? I don't want it black. I would like it green, please. So then you can see it. Pi to the left. So where is this cool new spot that I'm at? Well, it's negative pi because I was at 0 and I subtracted a pi, negative pi. From that point, I can now start doing my sine pattern. I want to go on, up, on, down, on. And since I've got those 2 last tick marks, I might as well just keep going with my pattern. You don't have to, but it's just fun. I don't know, just making that pattern is pretty fun. I'm not normally a fan of graphing. There's something about graphing these ones that's it's just peaceful. On, up, on, down, up. It's great. There's my graph. Oh, I missed my little arrow there. Okay, done. In this example, again, we've got a phase shift. This time it is pi over 4. Ooh. But again, it's spelled backwards and weird. So even though it's subtraction, we want to go to the right. So it's the opposite way that you would think when it's in the inside. It's all backwards and weird inside of the function. Our b value is 1. There's still a 1 right next to that x. So our period is going to be 2 pi over whatever our b value is, which is 1. So that is 2 pi. And our amplitude is going to be 1. So there's a 1 right in front of there. So that's how far up and down we need to shift. So yeah, let's do all those things. Here we go. Whee! 1, 2, 3, 4. Write your period. 2 pi. Halfway point is pi. My amplitude is going to be 1 and -1. And then I want to graph that pi over 4 to the right. Well, I'm going to get myself a little bit of extra help here because this is going to be pi over 2. And I want to go halfway to that thing because that would get me to pi over 4. So normally I would start right here. I want to go about like half-ish way to that spot. So as I graph my points, I'm going to need to stay in between the tick marks. If I wanted to, I could put like little tick marks in between. In fact, why don't we? Let's kind of put little tiny tick marks in between. So I'm going to follow these ones because I still want to be spacing them out to the same amount. So we're not stretching our period. We just want to keep in between. Since that first one was in between, all of them are going to be in between. So let's do our pattern. So we go on, go off the little tick marks, up, on, down, and then, oh, I'm short a little tick mark. I better just sneak that last one in. There we go. Right there. So then here is my sine curve. Woo! It's a little pointy, but that's okay. The next transformation that we're going to talk about is the vertical shift, or it creates what we call the sinusoidal axis. The sinusoidal axis is the thing that we're wobbling up and down between, the middle part of our curve that's going up and down. What's right in the middle, that is our sinusoidal axis. Now, fortunately, the sinusoidal axis follows normal things. If you add, you go up. If you subtract, you go down. Great. It's not all backwards and weird because we're not inside. We're actually outside of our function. So if I had this function and I wanted to graph it, I would identify all the things that I would do normally. Now it's going to be a little silly because most of this does nothing. The only transformation we can see is that sinusoidal transformation. But it's nice to think about, hey, there's no left and right. Our amplitude is a nice normal thing. Our b value is 1. So our period is just locked at 2 pi. We do need that sine thing. Let me get that real quick. There we go. So we want to follow our normal pattern. Write our 4 things out. 1, 2, 3, 4, and then we write our period. And then our halfway point of pi. Now, the next thing we actually do is now is the point where we actually think about our sinusoidal axis and that up and down shift before we think about the amplitude. If we think about before, we would write our amplitude of 1 and 1, and we would wobble along our x-axis because that's where the sinusoidal curve used to sit. However, we have a shift. And so when we wobble up and down, we want to wobble up and down from the axis that we're about to draw. So we'll make a dotted line to represent it. So this is going to be 3 up. So we'll go up 1, 2, 3. And this is going to be where we're going to be wobbling between. So I draw a horizontal line to represent that sinusoidal axis. Then from that thing, we want to wobble our amplitude. So we'll go down to 2 and up to 4 because we want to go up and down 1 from our sinusoidal axis. So from this orange line, we want to go up 1, and from this orange line, we want to go down 1. We don't have to move anywhere left and right, so that would be the next thing that we would deal with, but now we're all set to graph. So we start on our sinusoidal axis, we go up from our sinusoidal axis, down, on, and then up. We were doing that all before, but it was always the x-axis that we were wobbling between. It's the same idea. It's just the thing that we're wobbling on is now up at some other value, or it could be down at some other value. In this example, we've got another sinusoidal shift thingy. It's 3, and it's going to go down. Nothing's going on with our C value, so it's just 0. Our B value is boring. It's just a 1, so our period is just going to be, it's 2 pi over B, so 2 pi over 1. So it's just 2 pi. And then our A value is just 1, so we're going to go 1 up and down from our sinusoidal curve. So we draw our graph. Why didn't I write the N? Why is that orange? There's so many problems. I'm going to leave some space below because I know I'm going to be shifting down in a bit. And I go out 1, 2, 3, 4 tick marks, and I write my period of 2 pi, and then another pi. And then I draw my sinusoidal axis after my period. So I go down 1, 2, 3, And that is where I'm going to draw my sinusoidal curve down here at -3. So bop, 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 bop. And then I want to shift my amplitude off of my sinusoidal axis. So since my axis is down here at 3, I want to go up one, down there at -3. I want to go up 1 and down 1 from -3. So I'll wobble between -2 and -4. Cosine starts up from my sinusoidal axis, so I want to start right above the sinusoidal axis. Not above the x-axis, above the sinusoidal axis. Why is that green? It's supposed to be purple. So up on the sinusoidal axis, below the sinusoidal axis, on the sinusoidal axis, and then above the sinusoidal axis. It was always technically the sinusoidal axis that we were wobbling between, but it used to just be the x-axis. Now it's all kinds of things. Those are all 4 of our transformations at this point. So we know amplitude, period, phase shift, and vertical shift. Well, hopefully we do. A reminder that phase shift is backwards. If you add, you go to the left. If you subtract, you go to the right. However, vertical shifts, your sinusoidal shifts, are normal. If you add, you go up, and if you subtract, you go down. It's just when it's inside of that function, it's all backwards and weird. Make sure also that this b value is always factored out. If it is not factored out, you must factor it out first. Thanks for watching this video. Have a great rest of your day. Bye-bye.